have some fun with magnets and learn its properties. It is said there was a shepherd named Magnus, and he used to take his goats and sheep to the nearby mountain for grazing. One day, his stick, which had a small piece of iron attached to it, got stuck to a rock. This is how natural magnets were discovered. Children, you must have seen crane rolling over heap of junk. When the longer arm of the crane lowers a block over heap of junk, what does happen? Let's see. It starts picking up pieces of iron junk from the heap. Many pieces of iron junk were sticking to the block. Naturally, there must be magnet attached to the end of the crane that was picking up iron from the junkyard. Have you seen pin holders in which pins seem to be fitting onto the holder? And pencil boxes in which the lid fits tightly without a locking arrangement. And now, in the chess, there must be a magnet attached to all these pieces. That is why you can play them in moving train or bus. In all of these, the pin holder, the chess and the pencil box, there must be a magnet attached to it. Let's do an interesting activity with magnet. For this, we require a paper cup or a plastic cup, thread, clip made of iron, magnet, stand. Fix the paper cup on a stand with the help of a clamp. Attach thread to the iron clip and attach the other end of the thread to the base of the stand. Let's see what happens if we bring the iron clip near the base of the cup. It falls down. Let's try again and bring the iron clip near the base of the cup. Oh, it falls down again. Now, let's place a magnet inside the paper cup and bring the iron clip near the base of the cup. The iron clip hangs in the air without any support. Let's see what happens if we remove the magnet from the paper cup. The iron clip falls down because we have removed the magnet from the glass, and magnet attracts objects made of iron, and the clip was made of iron. Let's try again. Let's place a magnet inside the paper cup. And again, let's bring the iron clip near the base of the cup. It's hanging in the air. Let's see what happens if we remove the magnet from the glass. Oh, the iron clip falls down. Let's do another interesting activity, and let's see now what the Bujo and Paheli ka Pitara has got for us. Well, we have inside the Pitara quite many things. Let's see which all objects get attracted by the shepherd's stick. Let us move it around. We've got this made of cloth. It's not getting attracted. Not this foil, not the toothbrush. Well, a small toy, but it's not getting attracted. Yes, we've got few paper clips and they've got stuck to the magnet stick. Let us keep it in the pitara. The dice not getting attracted, not the ball, neither the scale, not the pencil, a glass bottle. The doll is also not getting attracted. Well, we've got here something. It's a pair of keys. Let's put it in the pitara. Not all the coins, but we've captured one coin. Well, we've got a nail also. Now, let us try to see what is common in all these materials. Let us now prepare a table and classify the materials of which these objects are made up of. We have a bottle. The name of the object we will write it as bottle. The material of which this object is made up of is glass. So let us fill it up. Glass. Whether this was attracted by magnet stick or the magnet, yes or no? So it is no. Well, we have another object. It's a pencil. So we have a pencil here. Well, it is made up of wood. And this was also not attracted by the stick. So we write no here. Well, now we have key. They are made up of iron. And it was attracted by the magnet stick. So we write yes here. Next we have a ball. It is made up of plastic. And even this was not attracted by the stick, so we write no here. We have a coin. Material which the object is made up of is iron. And this was attracted by the stick. Yes. Well, the next item is a nail. Material which the object is made up of iron. Attracted by magnet stick? Yes. Now let us find out what is common in all the materials which were attracted by magnet. Well, we can see from the chart that these materials are made up of iron. Now let us find out what was common in the materials which were attracted by the magnet are called magnetic material. Here, keys are made of iron, coin is made of iron, nail is made of iron. So we can conclude that the materials which are made up of iron, they get attracted by the magnet, and they are known as magnetite materials. That means magnet attracts certain materials, whereas some materials do not get attracted by the magnet. The materials which get attracted by the magnet are called magnetic materials, such as iron, cobalt and nickel. Materials which do not get attracted by the magnet are called non-magnetic materials. Let us find out which materials did not get attracted by the magnet. Bottle, which was made of glass, pencil, which was made of wood, and ball, which was made of plastic, did not get attracted by the magnet. So examples of non-magnetic material are glass, wood and plastic. Let us find out whether soil or sand is magnetic or non-magnetic. Rub a magnet in the sand and pull out the magnet. Are there some particles of iron sticking to the magnet? Well, yes. Let us gently shake the sand particles. We can see some particles of iron sticking to the magnet. Now let us remove the particles. And repeat the experiment. Again, rub the magnet in the sand and pull out the magnet. Still we can see some particles sticking to the magnet. These are the particles of iron which have been picked up from the sand. Let us find out whether soil is magnetic or non-magnetic. Rub a magnet in the soil. And pull out the magnet. Still we can see some particles sticking to the magnet. These are the particles of iron which have been picked up from the soil. That means the sand or soil contains some particles of iron in them. Try this activity near your home, near your school or places of holidays you visit, and tabulate it in the form of table given here. You may write the name of location as near home, and in this column, did you find iron filling sticking to the magnet? You may write many, very few or none depending on the particles sticking to your magnet. So near your home, when you tested, it was many. Similarly, when you rub the magnet in the sand near your school, we may fill it up as near school. Particles sticking to the magnet were very few. You may find some other locations and fill up the table. We can conclude by saying that sand or soil can be magnetic or non-magnetic. Let us test from soil picked up from different location to find out whether it is magnetic or non-magnetic. We take the magnet, rub it in the soil and pull out the magnet to see whether particles containing iron are sticking to it or not. Well, this soil is non-magnetic. So, we understand that soil or sand can be magnetic or non-magnetic. Let's do an interesting activity with magnets and learn more about magnets. Spread some iron fillings on sheet of paper. Let's spread the iron fillings evenly on the sheet. Now let's place a bar magnet in the center. What do you observe? Do all the iron fillings get stuck evenly all through the surface of the magnet? Or do they get stuck to some parts of the magnet more than the other? Well, let's remove the iron fillings and repeat the activity. Spread the iron fillings again. Do you observe any change in the pattern with which the iron fillings get attracted by different parts of the magnet? Most of the iron fillings are attracted towards the two ends of the bar magnet. You can do this activity by even using pins or iron nails instead of iron fillings, and even by using different shapes of magnet. Let's try doing this activity with horseshoe magnet and cylindrical magnet. Do you observe any change in the pattern? The pins are getting stuck to the ends of the magnet, and these ends are the poles of the magnet. Do you find that the bar magnet always rests in a particular direction? We find that a freely suspended bar magnet always stops in a particular direction, and that is the north-south direction. Now, you may use the direction of the rising sun to find out the direction of the east. You have to stand facing the rising sun, and to your left will be the north. Use the direction of the rising sun in the morning to find out the rough direction towards east. Using this, you can figure out which end of the magnet is pointing to the north and which points to the south. The end of the magnet that points towards the north is its north-seeking end or north pole. The other end that points towards the south is called south-seeking end, that is the south pole. In front of you is the east direction and behind is the west direction. So this side is the north and the right side is the south. This is how we find out the direction north and south from the position of the rest of magnet. All magnets have two poles, whatever their shape may be, whether horseshoe, cylindrical or bar magnet. And usually north and south pole directions are marked on the magnets. This property of the magnet is very useful for us. For centuries, travelers have been making use of this property of magnets to find directions. Later on, a device was developed based on this property of magnets. It is known as the magnetic compass. A compass is usually a small box with a glass cover on it. A magnetized needle is pivoted inside the compass. The compass also has a dial which shows the directions on it. Its needle always points to north-south direction when it comes to rest. You can make your own magnetic compass. For this, you require a magnetized needle. For making a magnetized needle, we have to rub the bar magnet on the needle along its length without lifting it. Once you reach the other end, you have to bring it back to the same end as you started and keep on doing it several times. After we prepare the magnetized needle, we insert it into a foam or a cork and place it in a trough or a bowl containing water, and place it in a bowl full of water. Care should be taken that needle should not touch the water. Let it rotate freely and observe in which direction it stops. Your compass is ready for use. Note the directions in which the needle points when it comes to rest. Let us play another interesting game with magnets. For this, we require 2 toy cars. Let us name car red as car A and the yellow car as car B, and place bar magnets on top of each cars. Now, in car A, we have south pole towards the front of the car, and in car B, we have north pole at its rear end. Let's see what happens if we bring the 2 cars closer to each other. Well, the 2 cars have collided. Can you guess why it happened? In car B, we had north pole facing the car A, which had the south pole. So, we can conclude that unlike poles attract each other. Let us now change the positions of the car so that the rear ends of both the cars are facing each other. And see what happens. The 2 cars are moving away from each other. What happened? Why did they move away? Because like poles repel each other. Well, children, you can play such interesting games at home also. And now let us summarize what we have learned today. Magnetite is a natural magnet. Magnet attracts materials like iron, nickel, cobalt. These are called magnetic materials. Materials that are not attracted towards magnet are called non-magnetic materials. Each magnet has 2 magnetic poles, north and south. A freely suspended magnet always aligns in north-south direction. Opposite poles of 2 magnets attract each other, whereas similar poles repel one another.